all the component here. Okay. So as you can see the front line here, can you see my circle, right? Okay, guys, can you see my circle?
Yes.
Okay, the front line here actually is 24-watt positive. Okay, where we will get the power supply from here. And then for each component here, this is the lamp. Okay, there is a 2 point here. Okay, 2 port here, where we're going to pin our wires here to let the electric flow in and flow out. Okay, in order to use this component. This one is the lamp with one is the green color, and this one is the yellow color. Red color. And this is the button lamp. That means this one can be a button and is a button and also lamp. Okay, this one is the yellow color and green, and this is the buzzer. Okay, and this one is the port for the selector. Sorry, it's the port for this for the pilot lamp. Okay, after that you will see it. Okay, and this is the push button. This two is the push button, and this two actually is the normally closed push button. Okay, and this is the selector switch. Okay, which we will latch the things like when we turn on, they will permanently turn on forever. And this is the emergency stop button. That means if we press this one, we will cut off the power supply. Okay, so if Mr. Cho Kai Sing
Sir.
Mr. Cho Kai
Yeah, Kai-Sing say he is outside and it's raining now, so he cannot come in immediately.
Okay, you tell him to join the class afternoon class.
Oh, okay.
You tell him to join the afternoon class. That's okay. Okay.
Yes. Okay.
So without further delay, then we start our class. So the practical one actually is about all the very fundamental component. Okay. There is required to do the push button and pilot lamp, and selector switch and tower light, and also push button light and the buzzer, and finally emergency stop. Okay, so after you watch the video, then you can write your observations. Okay, to put it here, the result. Okay, then you need to do some discussion here. So if you want to have a better if you want to have a better presentation, maybe you can crop some picture as your observation to put aside. Okay, so that you are more presentable during you watch the video. So what we will go to the practical one, and the push button and lamp first. Okay, now I will let you watch the video. So all your video actually is available in the Google Classroom, and all the material is there. So if you want, you can turn it on, and you can watch it. Okay, repeatedly. Okay, so first of all, we will go for the first experiment. Okay. So as you can see, actually this one supposedly you guys need to do it, but somehow because of this COVID-19, you don't need to go back to school. Okay, so we will ask the technician to do it for you. There is a plus and minus point here. The plus point is the the experiment that we do definitely is correct. But the minus point is you don't have the chance to do the to pin yourself. To this port. Okay. So as I mentioned earlier, the first row here all is 24 watt positive. So we get the power from it, and then we straight away go into the lamp here. Okay. And then we connect to our button. So the button here, the black color here actually is a 0 watt or neutral or negative also can, up to you. So this is the requirement. So what you need to do is refer back to the drawing, okay, that you need. The figure, and then you need to pin accordingly, and then try to do the connection wiring. You need to understand why you want to pin that. So if you're unable to look at the label, okay, then you can go back to the picture, okay. So this is the observation and the result. So if you want, you guys can send me the report in a soft copy. Then you will give me the observation, okay, and then this one can prove that this one is done by you, okay. And this is the first experiment. Any question? Hello? Any question? Huh?
The report, is it written?
Sorry, I can't hear you clearly.
Hello?
Yes.
Is the report written
Type. Because I think you just straight away can copy from my report there. You just add in. You don't need to type everything. You just add in the things. For example, maybe you if you want, you can add in some pictures. Okay, so that your report is more presentable. Okay, so I can give you even more marks. Okay, on that. So you don't need to print me the hard copy. You just give me the soft copy, and then all your report must be in the PDF form. So that means you use your Microsoft Word. After you're done, you have nothing to add on. Then what you need to do is you just save as a PDF file. Then the Microsoft Word will help you to convert to PDF file. Then I will mark your report as the PDF file. Okay? Do you guys understand? Yeah? Can follow, right? Hello? Give me some response. Else I don't know whether you are in or not. Okay.
Yeah.
So this is the first experiment. Okay. So you have to see this experiment is the push button and the selector. Okay. So we will go for the second one. Okay, this is the second one. I already actually you can really go back to the video, and then after that you can watch again by yourself. Now what I'm trying to do is I get the positive source, and then plug in into the selector switch. This is the selector switch. Okay. And then this is the pilot lamp. So all here is a red, green or amber color or yellow. So this is how we do the pin wire connections. So for this one, if you want, actually, you need to look at the look at the photo so that you could understand. Okay. So this is the main control. Okay. This one is only control for the red color. If I didn't turn on the lamp, the first switch, the whole thing won't work. Okay, you need to observe again carefully. Okay. If I turn on this one and this one, both is turned on, then all is turned on. Okay, if I turn off this one and I turn on this one, the red color will not function. They won't have the light. Okay, this is the one. And then you can repeat it and look for the observation and then write it in your report. So the next, then we will go for the third one. By the way, do you have any question? If you have question, you straight away ask me. If you don't have the mic, okay, then you please ask your friend to question, okay? Because once I turn on the presentation mode, I couldn't see the chat. I couldn't check the chat, so I cannot see whether I cannot see the question. Even if I check back the chat, there will be quite late already. Okay, maybe 1 hour late, half an hour later, then only I will see your questions. This is the third one. This is a push button light and the buzzer. Okay, we just need to connect accordingly. So we get a positive source, and then we use the selector switch to control the overall. After that, after the selector switch, then we go to the push button. So if you look at the figure label, because now you can't see what is he doing. Okay, so you look at the figure. I mean the label. Sorry, the picture they are given, the label. Then you can look what is trying to do. Okay, and also from the figure. Okay. So after this, when you turn on, the push button will light. Okay, when you press the push button, then the light will turn off and the buzzer will sound. Okay, once you turn on the push button. So now I would like you guys. Can you guys differentiate the difference between the selector switch and the push button? Anyone can answer this? Selectors switch here and the push button. Anyone can answer me the difference between these two? The selector and the push button. Can anyone answer these questions?
No, sir, we don't know.
Okay.
Only the one input. The selector switch. Not sure.
Okay. Very good. You're almost there. You're almost there. But now I'll give you even more detailed explanation. Actually, the push button is just like our keyboard. You know, our computer keyboard. Okay. So, for example, like A alphabet, there is a button there. Okay. If I press one time, they only give you one signal, A. I mean, appear in your Microsoft Word or whatever typing. They will appear one time only. If you keep on pressing, they will give you a lot of A. They will give you a lot of A, correct or not? Okay. And another example of this switch is our switch for our light. Okay. If we want to click turn on the light, we just give one signal, and this signal will stick there forever. Okay, they won't change one. They will stick there forever until you unclick it. I mean, you turn off. You get what I mean? That means one is stick or latch for the latch for your signal. One only is give you one signal only. For example, like aircon. Okay. Have you ever think that the remote control, right? There is a button, remote control. There is an on button and off button, right? Correct or not? So why in these circumstances we want to use the push button, not to use the latch button? I mean, not to use our switch. If we want to, because for the inventor, what they need is they only need a signal. Okay, your intention to turn on the aircon, one is enough. They no need to latch forever. Okay, because if you put it for the latch forever, then the user might need to turn off again. Okay, then a lot of time you cannot do the automations. For example, like when I turn on the aircon, okay, I can easily make it. I can write in my program, okay, to latch the signal 1A, okay, latch the signal on forever, and then I can do it in my program to turn it off automatically. I no need to need the user to give me the second signal. Okay, this is the usage. Do you guys get me what I'm trying to say? Hello?
Yes.
Yes.
Yeah.
Yes.
Yes.
That means sometimes if we select to use the switch button, which means we need people to give the second signal. Okay, on and off 2 times. If I use the push button, okay, once I get a signal, after that the inventor actually can use the programming. Okay, they can use the programming to program the program so that we can continue to get the signal, and then we also can stop the signal without the human interfere. That means that I no need for the second input from the user. This is the major difference. Okay. So actually, this push button and the selector is a very fundamental usage in the automations. Okay, you need to understand this. Okay, so next we will go for the third one. Fourth one, emergency button.
I forgot to mention you.
Huh?
Yeah. I come in late. I'm passing to.
You come in late. What's your name? What's your name? Oh, Chua you managed to go back, come back. Okay. Oh, okay. Then I can mark you. So now we go for the practical one, the emergency stop button. Okay, as you can see now we are referring to this. Okay, emergency stop button is one of a very important button that every machine should have. Okay, what is the usage for this emergency stop button? Okay, anyone can answer me?
To stop the machine.
Yes, just stop the machine. Why we want to stop the machine?
In case of emergency.
Yeah. Okay. That means actually what this emergency stop button will do is actually this is the latch switch. Okay. So when we don't want to use it, this is normally closed. They will let the machine to work. Okay. I mean to let the power to pass by, and then the whole system will go. Okay. When there is an emergency cases, okay, or case, then what you need to do when I press the button, then will break the circuit. That means the entire whole machine, they will face a no power supply. Okay, this is the usage. Okay. So when you see when I press it in, after that I need to release the emergency button. I need to twist a bit. That is the a bit different from the normally stop button. Okay. I show you again here. You see, I need to twist so that to release the button. Okay. So when I press, that will stop. And then this is what I do is I use the light to turn on the light to indicate that we already successfully done the job. Okay. For example, before that, the machine is in the normal circumstances. Okay. Then this emergency button, they will break the circuit. They will let the circuit to flow in. Okay. If in the case there is an emergency, then we need to press the button. Okay. After we press the button, we need to release the button. Only then the machine will resume. Okay. Else they will stop forever. Okay. This is the first 4 exercise that practical that you need to know. So, do you guys have any more question on this one? For the first 4, or you need some time to do some digestions, guys? Or you want me to continue?
Continue, sir.
Continue. Okay. So the next one we will look into the button.
Okay, it's lagging, sir.
Lagging.
Continue.
Okay. So the next one you need to look into actually is the relay. Okay. Relay is a very important component that we use to contact with the actuators. Let me show you the picture first. Okay, this is the relay, and this is the Omron blind. So relay have 2 types. I mean, in our apparatus we have 2 types. One is a 2-pole and one is a 4-pole. Okay. So for example, like 5 to 8 is normally open. 1 to 4 is normally closed. 14 and 13 here will be the power in out, and this is the contact. Okay. So what we need to do is, in order to use this relay, that means this relay, when you trigger it, okay, they can control 2 switches. That means they can control 1, 4 and 5, 8. 1, 4, 5, 8. Sorry, 1, 4 is normally closed at the initial status, and this 5, 8 is normally open. So what we need to do is we just need to pin the point here. This is the point come in, and this is the point come out. Okay, and this 13, 14 we will direct connect to our power source. So we also have another type relay, which is we call 4-pole. I will show it to you. Okay, this is the 4-pole relay. That means one relay actually it can control 4 switches. Okay, there is 1, 2, 3, 4. Just now we have only 1 and 4. This one they straight away can 1, 2, 3, 4. That means they straight away can control 4 switches. That means what it means by, if I have 1 turn on, if I close one circuit, then 4 different switches will be turned on, just like our together they can control 4. Okay, so after that we look at the video. Okay, So this is a two pole. So we will connect all 4 ports here, normally closed and normally open. So of course we get the power to power up the relay first. And this one, the negative, we will control to the another switch, and this switch will connect to the negative, so that we can use this switch to control the relay. Okay. So we will use the 4 lamp here. Okay, the bottom part here is a normally open pin. That means, can you guys differentiate what you mean by normally open and normally closed? Guys, do you understand what you mean by normally open and normally closed?
Open means empty.
Not in electrical term. Open not mean empty. No, sorry. Actually, normally open is when a circuit, okay, for example, if you want to pass the electric, okay, what you need? You need the circuit all is closed, okay, all is closed. That means the switch that you get is closed. Okay, for example, for this one, at the initial condition, we turn off the light, we turn off the power, okay, but these 2 buttons, okay, they have the power. That means in this circuit, at the initial beginning, the circuit already closed. That means they already turn on the power. I mean, they let the electric to flow through. Flow through. That means we call normally closed. And then for okay, for example like this one, okay, at the very initial beginning, there is closed. That means the electric can pass by. And this one is normally open. Is when we want to turn on, we must turn on. We must close the circuit. Then only these 2 lamps will turn on. That means the circuit is not closed. We need to get the signal from the user, okay, in order for the electric to pass by. And whereas for this one, at the initial, we no need to get the user signal. The machine is working, okay. When we get the signal from the user, we will break the circuit. This is the 2 different. Do you get me, you guys? Hello, you guys is very quiet compared to the DMG.
Yes, I get it.
Anyone other than you? How about the others? This is a very basic and very important concept you need to understand. Normally open means at a very initial, we didn't close the circuit. Okay, we need to get the signal from the user to close the circuit. That is normally open. If for normally closed, yes, at the initial beginning, at the initial, we no need to get the signal from the user, but the electric will flow through. When we get the signal from the user, actually we are we are break the circuit. You understand? Just like the emergency button. Do you guys think that the emergency button is a normally open or normally closed?
Close.
Open.
Okay.
Close.
Close. How many of you say close?
Me.
Huh? Oh, yeah, cannot see you.
Me,
How many of
me.
you? Okay,
All
me.
of us.
All of you. Yes. Actually, it's normally closed. That means at the initial, the electric can pass by. Okay. So if you press the button, administration button, that will break the circuit. So this is only used that we want to use for the stop button. Okay. And normally all the stop button actually is a normally close button. So in this relay, they can offer you two choice. The first choice is if I want to have a normally open function, then I will need to connect to the bottom here, 5 or what? I forgot the numbers. Okay, let me watch first. 5 and 8. Okay, if I want to have a normally open function, normally closed function is 5 and 8. If I want to have a normally closed function, then I need to connect my wires to 1 and 4. You understand or not, guys? And then if you connect wrongly, they will give you different meanings. Okay, so this is for the normally closed and normally open function. So next we will look at the 4-pole. Okay, basically the 4-pole, they're having the same procedure. Okay, but if you look carefully, the way they pin is different. I mean, from the figure. Okay, they all pin at 5, 6, 7, 8. So for usual, we get the power. Okay, and then we connect the switch to you by using the selector. After that, from the selector, we connect to the 0 watt. Then now we will use power to turn on first. And we will pin it with 5, 6, 7, 8. You see, this all the 5, 6, 7 actually is a normally open function. So what will you guys expect? I mean the answer for the light, if they are all connect to the normally open function. Anyone can answer me, please? Okay, now you can see when I turn on, all will be on. When I turn off, all will be off. Actually, why this happen is because I click all the button with the normally open connections. Okay, if the pilot all put in the normally closed connections, then when I turn on, all is off. Okay, so when I turn on, all is off. When I close it, all is on, the light. Okay, this is the opposite. Just like what you have just now. To understand this one, normally open and normally closed concept. So the next, we will move on to the latching. Okay, the latching circuit. Okay. Okay. This is a relay latching. What you mean by this relay latching means when I press a button, they will turn on forever. Just now I did mention to you, right? The latching, because normally push button, they only can give you one signal. If we want to make the signal to stay on forever, then actually we can internally adjust our program or the wirings. Okay, so now the technician will demonstrate how we adjust our wiring in order to do the latching. Which means when I get a signal one time from the push button, the light will turn on forever until you turn off. Okay, so this is because we connect to the normally close button. So initially, now can you see that? Last time when we want to turn on, I mean for the first experiment, when we want to turn on, then we press. Okay. Then we press. Okay. This one to release. Okay. Unless we use my hand to press this button. Okay. If I press the button here, the red light will no longer turn on. They will go to here because we are using the latching circuit. Okay, this is different from what we have in the very beginning. Okay, very beginning, where at the start, when we press the button, they will turn on. When we didn't press the button, they will turn off. As long as your hand is moved, but this one is different. It's latching. When I turn on already, when I press the button, turn on already. If I don't press the turn off button, I mean the stop button, this one will turn on forever until you give another signal. Okay, so this is what we mean by latching. So if you start to use the PLC programming, okay, then you will know that this latching actually is very important. Or there is another term called seal-in circuit. That means actually we are sealing the circuit by itself in order to get a permanent turn on. Okay. So I will stop here for 5 minutes or 5 to 10 minutes. So you guys can actually to refresh. Okay. What actually I did show to you guys. Okay. Or maybe you want to go to toilet, you can do it. Okay. We just temporarily stop for 5 to 10 minutes. Okay, guys, should we continue?
Sir, yes, yes.
Okay, sometimes I even don't know whether you are there or not. Okay, if we continue, then we use another switch, which is called opto isolator. Okay. So here, actually, it's the same as the relay. Okay, they won't have a direct contact to the switch. For example, like okay, I want to use a small current. Okay, uh, have you guys ever do the workshop for the arc welding? Have you do the practical arc welding, guys?
We did it in Sem 1.
Yeah, good. Okay, so as you know, the arc welding, we require a very high current. Why we need to have a high current? Because we want to melt the welding material. Okay, we want to melt it. If we use our hand to start to start the welding machine, sometimes it's very dangerous. Okay, that's why we will isolate it. For example, like I will use a small switch to turn on the relay, okay? And then the relay will close the contact for the arc welding. Because for the arc welding, the voltage is 415 volt, and then the amp may be more than 13, okay? Actually, it's quite dangerous, okay? Because more than 13 means anything short circuit or whatever happen, you straight away gone. Nothing can help, okay? So what we try to do is, in order to protect the user from the direct contact to the high voltage, what we try to do is, we will use the relay, okay? When we give the power to the relay, inside the relay, they will do the electromagnetic flux, okay? The electromagnetic flux will attract the switch here so that it will close the circuit. Once this circuit closed, and then the machine will turn on. So this is where we want to use the relay, okay? So relay is one method. Another method to do this is we also can use the opto isolator. And this opto isolator, the concept is different. For the relay, they will using the electromagnetic flux, okay, to attract the switch. Then for the optoelectric, what they do is they will emit the light. Okay, this is the diode. They will emit the light, and the light when you emit, then they come to the transistor here, and then the transistor will become low. I mean the resistance inside will become low, so that the current can flow through. Okay, this is the two different way of turn on the switch. Okay, the working principle. But somehow the function for both of them is the same. Okay, so normally the opto isolator is used for the small current. Okay, especially like using in the our motherboard. Okay, all the electric equipment. Then we will use opto isolator, and the relay actually is more to the machinery for the heavy duty one, or maybe for very high power. Then we will use the relay to protect you. Okay. So now we look at the video. Oh yeah, sorry, I forgot to let you have the photo of the opto isolator. Okay, this is the opto isolator, how it look like. Okay, again, basically this is the same where we will pin the point here. Okay, so the bottom part actually is the counter. We will pin the point here, and then we will use that one to control. This is the positive side or the power side. Okay, this is an opto isolator. First of all, we will power up. Okay, this one we have the switch power. Then you put the light. So that's all. Very simple. The working concept is we will turn on the light. Okay, this one we turn on. We don't have the direct contact to this. We will use the opto isolator to turn on. Okay. Sometimes, if you have a very high voltage, we also can use the oscillator to isolate to turn on the low voltage power. For example, like maybe your circuit board is less than 5 watt, is 24 watt, 240 watt. If we direct connect our 240 watt into the circuit, then you straight away will burn the circuit. So what you need to do is we use the 240 watt to turn on 5 watt socket circuit, so that we don't have the direct connections. Okay, if we use the direct connections, your 240 watt will spoil the 5 watt circuit. Okay, or the PCB board. So this is also another usage for the opto isolator. Either we power up or we power down, so that we don't have a direct connections. This one I will discuss further in the chapter 3, okay, later on. This is fall under the conditioning protections. Any questions, guys? Okay, if no, then next we will go to the counter. Wait, I have a call. What? Okay. This is counter. Okay. Do you guys know what is the use for the counter? Any idea? What is the usage for the counter, guys? This is the counter. Okay. Any ideas? So this counter, they have a lot of pin here. Okay, if you enlarge it, you can see. Okay, Input 1 normally open, normally call RST is the reset. Log is your log out value. When you reach, then you know com is com will be the what? Will be the norm 0. Okay. Will be power this and how it look like, actually it look like this. Okay, the counter, and this is all the button, and all this button actually is connected to here. Okay, and this is a reset button, and this is the counter. Okay, this is counter, and then this is all the connections. So we need to pin it. What is the usage in the counter in automations? Can you guys give me some usage? I mean application of the counter. Hello. Hello. Hello?
Yes, sir.
Yeah, can you give me some usage? I mean the application of the counter, where normally we want to use the counter. This counter is one of the very important component.
Count.
Huh? To count. Yes. The function is to count.
Yes.
But the thing is, pardon?
Nothing.
Actually, the counter is they want to do the recording. Okay, when you go for the recording, that how many occurrence actually happen. For example, like if I want to do a packaging machine, okay, then I have I want to pack 5 orange in a bag. Okay, so what I need to do, I will use my sensor. Whenever the photo sensor, whenever the orange pass by my sensor, or I trigger my sensor, then my sensor will send the signal to the counter. And then what the counter do is they will record. Okay, for example, like if I drop 1 orange, trigger the sensor, record 1. Second orange, record 2. Third, record 3. Fourth, record 4. And fifth, they will record 5th. Because of I want to make my packaging machine is to pack for 5 orange. So I will have my, just now you see there is log value or preset value. I will set my preset value at 5. Okay. When the counting is reached at the preset value or log value, okay, then they will send a signal to trigger the machine or the user or the program that the count already met. So you can do your next actions. Okay. So maybe your next action will push the box away and place a new box and then do the counting again. Okay, by using the sensor. So if I use 5 orange, this can easily replaced by a human. Of course, the human, when you see, then you will know that actually there is 5 orange in the box. Straight away you can do. But if I ask you to pack a sweet machines, I mean for the candy machines, okay, the sweet, which I need a 200 in a pack. Then do you think that this is easily worked by the human? Or do you think that this is efficient if I use a human to do the counting? As you know, human will tend to be fatigued. Oh yeah, I talk too much already. Okay, let me show you the result. Okay, so this is start. Okay, so I press 1, I trigger 1 time. These are using button 2, 3, 4, 5. Then as you can see, when I press 5 times, then it's my log value. After that, I can press my reset button to reset it. Okay. So this is reset. Okay. Then 1, 2, 3, 4, 5. Okay. Then you will see the value actually they count 5 times. And this is what you want in your preset value. Then you will know that 4, 5. Okay. Then your light will turn on. This counter will help you to record the readings. So the counter actually is the occurrence based. It's not a timing based. Okay, there is a difference between the timing based and occurrence based. Okay, for example, like occurrence based means there is independent of the time passed by. For example, like if we just now the generation, right? I press 1, they record 1. Okay, so tomorrow I press 2, 3, 4, 5. Then they will record 5 times. But do you think this counter preset value will set is totally based on how many times you trigger the sensor? Okay, it's not based on how long you wait. Okay, which is different from the timer. Okay, the next I want to show you is the timer. You need to understand differentiate between the two. Even though the preset value that I can put or login value that I can put is 5 for counter and also 5 for timer. Okay, if I put 5 for timer means maybe the timer will wait for 5 minutes or 5 seconds, depend on your time unit base. Okay, but counter is different. After 5 seconds, for example, for timer, after 5 seconds, they will trigger the signal. But for counter, they won't trigger after 5 seconds. They will trigger as long as your occurrence have happened for 5 times. Then they only trigger. Maybe today you press 1. 2 years later, you press 2, 3, 4, 5. Then only they will show you the log value. Okay, they will trigger the log value. Whereas for timer, if you set for 5 seconds, even though the thing happen or not happen, the timer after 5 seconds, they will straight away trigger. Okay, so I show you the timer first. After that, you could be more understand. And this all actually is a very fundamental component that require for the automations. Okay, you need to understand all these basic first. Actually, the timer, what the timer is what's the difference is this timer actually is a relay. Okay, they will use a time delay. They add on the time delay here. Okay, to control the time. Okay, so once the time delay is done, they will straight away turn on the switch. This is how we power up first. Okay, this is power up. Then you will see that we will connect all this in a normally open loop.
Sir, are you sharing the screen?
Oh, sorry, man. I didn't. Sorry, guys.
It's okay, man.
Because too much sharing all this. Okay, sorry. So okay, can you see now? Sorry, just now. So actually, this timer actually is more like a relay switch. Okay, this is just now the relay switch. And this is the timer, okay? The timer is, they will add on the delay function here. That means this timer, we can do it automatically. We no need for human to do the touching. And okay, and also from here, you can see that the 1, 2, 3, 4, 5 in the initial condition is normally closed. They will connect the circuit, okay? Whereas for 5, 6, 7, and 8, at the initial, they don't turn on. They are open. When they turn on, when the signal turn on, they will close the circuit. Then they will let the power to flow 5 and 9. Okay. So this is a timer relay. So you can see now what they want to do. They connect all with the normally open. So first of all, we need to power up first. And we connect to this selected switch because we want to have a permanent effect to turn on. Of course, I also can put it with the button switch, but then you need to always press the button. If you release your hand, then your whole circuit will be break. Okay. So now you can see, right? Now what we do is we connecting to the bottom because we want to have a normally open effect. Okay. So the next thing is we need to set the preset value. Okay. So what we're going to set is we set in the 5 seconds. Okay, roughly 5 seconds. Okay. So what will happen? You will see they will turn on for 5 seconds and turn off. Turn on and turn off by itself. Okay, we no need to do anything. This is what is a very fundamental automation. For example, the real life application is if you have seen the landed property, okay, landed property or double story, I mean in front of their house, okay, maybe at the 8 o'clock, the wall, the fence light will turn on by itself. I mean without the owner, they turn off the light because they use the timer. This is exactly the concept exactly the same as our aircon button. Okay, have you ever used the remote controller aircon timer functions, guys?
Yeah.
That means for example, like because I know that 2 o'clock is very warm. Okay, I will reach my home at 2.